As our C functions grow larger, we'll want to write separate functions. So far, we've only written one function named main. And we'll begin writing several other functions that all have special purposes. All right, so a function is a group of statements that together perform a task. Right. They're going to be the building blocks of our programs. As our code gets longer, we don't want to write everything inside main. We'll see some examples in these tutorials of how to write a function that calculates the average or a sum, finds the largest number, finds the smallest number, all kinds of special purposes. Right? We divide our programs into these smaller pieces, makes the programs easier to understand and maintain as well, just smaller code sections to maintain. And then if we write them correctly, we can reuse them in other programs. Right? We've been using functions, besides writing the main function, we've been using functions that are already defined in other libraries. For example, printf, scanf, right? These had to be written at one time. They were included in another library, right? Which is why we include the header files, because they're defined there. We'll learn that later, right? And we don't want to have to write that code over and over again, right? We don't want to have to write the code for printf and scanf every time we want to use it. So writing functions, saving them, reusing them makes our development time easier and faster, less error prone as well too. So the general form of a function, it will always start with a return data type. It'll have a name, so the name follows the C identifier naming rules. And then in parentheses, it'll have a list of parameters. This list may be empty, or it may contain declarations of parameters, having a data type and a name. Right? The body of our function starts with the left curly brace, ends with the right curly brace. Within the function, we can do any other C, use any other C construct that we've already learned. We can declare variables, we can call other functions, we can write if statements, we can write loops. And so anything we've learned to do in main, we can do inside these functions. Let's take a look at printf. It's defined in the standard library. And if we go to the header file, we'll see that it's defined like this. Its return data type is int, right, for integer. The name of the function is printf, and its parameter list looks like this. Right? It has a parameter named format whose data type is constant char star. The ... means this is a variable length argument list, meaning we have to pass at least one argument to this function when we use it, but we may pass more. So that's how printf has been defined, and that's why we always call printf by its name. We at least have to pass that string of characters in there. Most of the time we ignore what printf returns. Printf tells us how many characters it writes to the standard output stream. We usually don't capture that information, but it does return that. If in this example we wanted to write a function that calculated the sum of two floating point numbers and returned that sum, right, we'd follow this form. Remember, return data type, function name, and parameter list. Right. So here's the function header: float, sum. Here are my two parameters, num1 and num2. Right. So the name of my function is sum. Its return data type right here is a floating point number, and then its parameter list. Both of the parameters in this list are of type float. One of them has the name num1, the other one has the name num2. Right? So whenever we put parameters in the list, these are just identifier names. We have to give them each a data type. Right? When there's more than one, we separate them by commas. It's up to us how many our functions have based on the way we write them. Right? So the return data type. We can return any data type from a function except using array notations. We're going to see, just like in main where we have return 0, we'll return some value that may be of any of these types, right? Long, char, int, short, unsigned, char, double, float. Void means that our function is not going to return a value, right? And there are pointer types as well. We have not yet studied pointer types, so we'll ignore that. But if we need to return basically information about an array, we'll do that through a pointer. What we cannot do is we cannot use array notation for return data types. So we can't say int followed by this array notation. We can't say any data type followed by this array notation as a return data type. Right. So the parameter list, once again, it's enclosed inside of parentheses. Each parameter in the list is specified by a data type and a name. Basically, you're declaring a variable here, right? You're declaring this to be of type float and you're giving it a name. You have to have the data type before the name, right? You can't skip that. Okay, so here's an example of what's legal. Here's a function named myFunction, right? It has two parameters in its list. One is named num1, the other one is named num2. Num1 is of type int, num2 is of type int. And what you might think you'd like to do, since they're both the same data type, is to write it like this, where you just say int num1 comma num2. We don't do that. That's not legal. The compiler won't like that. So each one has to have a data type. Just think of it as declaring a variable, right? Whenever you declare a variable, you have to use the data type and give it a name. Right? Otherwise, if you're not going to pass any information to a function, if the parameter list is going to be empty, you can use the empty parentheses, or you can put the word void inside the parentheses, which means the function doesn't have any parameters in the list. So either style. And then both indicate an empty brace. Right, so the function body will always start with the left curly brace and with the right curly brace. And then inside the function body, we can declare as many variables as we want. We can use any sort of legal C statements. And so if this function here, named average, we're calculating the average of two numbers, so it looks like we're going to calculate the average of A and B here. So we're passing a value to this function, two values for A and B. We declare these parameters in our list, both will be of type double. Within the body of the function, I've declared a variable named sum, right? Adding A and B together, storing it in sum, and then returning sum divided by 2, right? Notice then the data type of the expression we're returning, sum divided by 2.0, is double, right? Sum's a double, right? The constant data type, or the data type of this constant, is also double. This expression is of type double. That's why our return data type here is double, right? We have to match. So we're going to start using the return statement in a function as well too. We've used it main to return 0 at the end. A return statement will cause us to leave a function. Right? So when the function has a return type other than void, we have to use a return statement. So it's return some expression in C. Right? Any valid C expression, we've already done return 0 in main. It could be a mathematical expression. It could simply be a variable, so it'll return whatever's in that variable's memory. Right? It can be the result of an expression like this, which is a comparison that would return a 1 or a 0, depending on true or false. And like I said, the function ends whenever the return statement is executed. Right? And then the value of this expression is returned to the calling function. So we'll see later what it means when the calling function gets that value. If the function has a void return type, you can use a return statement just like this, return followed by a semicolon, so no expression, but you can leave that out. So most of the time you'll see functions that are written with a void return type not have the keyword return in here. Let's go back to our first example program that we wrote, hello world. Right. What if we wanted to write a function that displays the message hello world? Not just main, right? Pop this up here. Here's our hello world program that we first wrote, our first C program. So we have a function named main here, and all it's doing is writing out the message hello world. Well, what if we wanted to write a function that just always writes out hello world? It's a trivial function that you normally wouldn't write, but it's going to get us started on how to correctly write a function. All right. So one thing then we think about when we're going to write a function, we always think about what is the function's purpose, right? You want to ask yourself these questions. What is the function's purpose? Well, it's to display the message hello world. And then you ask, does the function need any information from the outside world? Outside world being information outside this function to accomplish its task, right? So outside world, other functions in the program. And we'll find out that other functions can pass information to our function if we need it. That's what we mean by, do we need information from the outside world? In the case of hello world, we don't need any other information because we're simply going to use a printf statement to display the message. When we don't need information from the outside world, our parameter list is empty, right? So the function has 0 parameters. Right? And then the last thing we ask is, does the function return any information? Well, if its task is to display the message hello world, we don't necessarily have to return any information. If we wanted to capture the information the printf returned, we could do that. But since we normally ignore that, we're just going to go ahead and say that our function does not return any information. Its return data type will be void. And whenever you name the function, we follow the C identifier naming rules. Right? Start with a letter of the alphabet or an underscore. Right? It can contain numbers, letters, or an underscore. Right? Can't be the name of any keywords, and it's case sensitive. Right? So in our case, we're going to name our function hello world. Right? And so when we write our function, then we'll write the header. Right? Name of the function hello world, parameter list. I could leave this empty, or we can put void in it. Our return data type will be void. Right? And then we start writing the code inside the body of the function to implement its behavior. Right? So I've got a lot of comments here, but just to remind you then, this left curly brace is the start of the hello world function body. The right curly brace is the end. Inside, we're going to write the instructions we need to accomplish our task, which is simply printing out the message hello world. When our code gets to the end of the function, that'll return back to where we called it. Right. Now the question is where are we going to place our functions and programs? Up until now, we've only written one function named main. And every C program will still have to have one function named main. Right? So we have to have one function named main, but we can have several other functions. And we can only ever have one main in our program. We can't have multiple mains. So for right now, we're still going to write all our source code in one file. Later, we'll learn to use multiple source code files. But whenever we write all of our code in one file, we have to define a function. We have to declare it before we reference it, so before we use it. Right? And we declare functions with a function prototype. Right? The function prototype is simply the way we define the function, what we also refer to as the function header. Here's its return data type, here's its name, here's its parameter list, right? And then it ends with a semicolon, right? This just simply tells the compiler that the function exists. So let's just take a look at what all this means in terms of writing a program. So let's just pop up code blocks here. Right, so we already have our hello world program, but now we want to write a function that displays the message hello world. Right, that's what we're doing. Right, so we said our return data type is void. We're just calling this function hello world. The parameter list is empty, so I could put a void there, or I could just go ahead and have the empty parentheses. So its function, its task is simply to print out the message hello world. As a matter of fact, it's simply to do this. I can take this out of main, right, put this up here. All right. And now I've defined a function named hello world. I've done so before main. If I want to use that function, so from within main, I'm going to say call the function hello world. So when I call a function, I call it by name. So the function's named hello world. We have the parentheses to indicate we're calling a function. Since the function parameter list is empty, my parentheses here are empty, semicolon. This will cause then our code to execute. All right, let's just go ahead and compile this. Good, we didn't get any warnings. We'll build it. Let's just do a run to cursor. So I'm going to put the cursor right here, right before hello world. Run to cursor. Right. My watch window pops up. Right. Notice then here in the watch window, there are no local variables. What's referred to now as local is I'm in the function main. So that means I have not declared any variables here in main. So there's nothing showing up here. Right. And there are no, where it says function arguments, if I had any parameters in this list, those would be filled in with its values, but none of that exists here in main. Right. Now, I want to step into my function. Right. So I'm going to use the step into. If I were to say next line, it would just go ahead and execute all the code in my function. Step into will show us how our code, how all this works. So step into. But when we call a function, it goes to where the function is defined, and it goes to the first statement here in this function. Right. It's waiting to execute this. Now notice once again here that I'm in the hello world function. We haven't declared any variables. There are no arguments, so the watch window is empty in that regard. Right? There are no local variables. Now I don't want to say step into. If I did, I would go inside the printf function. Let me just say next line. Right? And when it executes that line, we see that printf displayed the message hello world on our screen. Right? I'm going to say next line again. Notice we're here at the end of our function. So when a function finishes, it goes back to where it was called. Right? C keeps track of the address where this was called, so it knows where to go back to. All right, so next line. Right. So the next line to be executed after hello world was finished is simply the return 0 statement. Right? Our program doesn't do much, right? If I said next line, it would execute the return 0, right? And it would, if I say next line, our program just finishes executing, right? And if we just run this, right, without stepping through how the function works, write all the code, we see we get the same behavior as our original hello world. Like I said, normally we wouldn't write something like this. Right, if this is all our program had to do, we just write the code in main. But this is a good first start for us to learn how to write a function. Right. Now, notice I wrote the function, I defined it here before main. So main references the function. So what this slide meant, right, this slide that said, right, we have to define it before we reference it. Right, so a function must be declared before it is referenced. Right? Right. So I both declared it here with its header and defined its behavior inside here. So here's my reference. Since I declared it before it was referenced, I don't get any errors. But let's see what happens if we move this down here. So I'm going to move it below main. So here, main is referencing it. The way the compiler works, the compiler starts at the top of your file and starts working its way down. When it gets inside main, it looks at hello world and says, well, is hello world a variable that's been declared? Well, no, it knows hello world isn't a variable. It knows it should be a function because of the parentheses here following this name. And it says, oh, have I seen any definition or declaration of hello world? No, I haven't. I'm going to issue a warning. So let's just compile this. And I'm not quite sure. Let me clean my workspace. All right, let's compile. All right, now that we compiled, let's look at this warning. Warning, implicit declaration of function hello world on this line. What that's saying is that I have not yet told the C program about hello world. I haven't declared it. Simply because we moved it down here, the compiler hasn't seen it yet. Right? So if I want to write functions, if I want to define them in the code after, so in the file after I reference them, I use a function prototype. The function prototype is simply the function header here. So I'm going to copy that. I'm going to place that up here and put a semicolon after it. Right? We call this a declaration, and this is a function prototype. So declare the function, right? Here, this tells the compiler that later on it will find out how this is defined. So it'll find out its behavior. So when we say we define it, that's when we write the code inside the curly braces that actually then says what it should do when that code's executed, right? But here, this is a lot like declaring a variable, a global variable, right? We have it. Except we have a return data type, we have a name, and we have this parameter list followed by the semicolon. So now, if we compile, notice that warning goes away. That implicit declaration warning goes away, right? Our code still works the same as it did before, right? If I do a run to cursor here, all right. All right, so it's still waiting. I haven't executed this code. I have no arguments. So now if I say step into, well, now it goes down here where hello world is defined, right? Next line prints out our message, right? Once again, next line, and then my function, it goes back to where it was called and is ready to execute the next line. Right? The reason we put the function prototype here was because we actually defined our function below main. Right? If we don't have that very many functions, it's very easy to define them in the right order. But as the list starts getting longer, you want to start using function prototypes, right? So that you don't get those implicit declaration warnings. Let me stop the debugger here. All right, and that was our function prototype that we wrote. Function prototypes usually go at the top of the program, right after the pound includes, but before we start defining our functions. Right? And we saw the implicit declaration warning. That's what this section of the lecture notes discusses, right? And you're also given an example of that file as well. All right, so that is just hello world, our first function. Let's go ahead and write a second function, right? Something that does a little bit more. So we're going to write a function that calculates the sum of two numbers. And we ask ourselves, what should we name the function? Right? Once again, follow the C identifier naming rules. Most programmers follow a convention of starting their function names with non-capital letters. Right? So we could name our function calcsum. A parameter list. We have to ask ourselves how many parameters in the parameter list and what are the names of the parameters, what are their data types. Well, since it's your first function, that's a little hard to answer. But we said, what kind of information does our function need from the outside world? Right? In order to calculate the sum, the function is going to need to know the variables it's supposed to sum. This function should have access to those variables. We want to pass that information to the function. We want the function to calculate the sum and then return it. And then the return data type, well, the return data type we'll see is going to be whatever data type we make the sum in our function. Right. So here's what we know so far, right, to start answering those questions. Right. If we were to write out the function header in its general form, well, we could put a note here saying, well, we know we have to code in a return data type. The name was easy to come up with. And then here inside this parameter list, I just have parameters question mark. We don't really know that yet. We also know that we need a curly brace to start the function body and a curly brace to end the function body. So we've got the general form down, right? And let's go ahead now and make the assumption that we're just going to add two integers. Right? If we're going to add two integers, we could write a function that looks something like this. So inside the function, declare two integers, num1, num2, right? And an integer variable named sum. Well, I just said, arbitrarily said, let's assign 1 to num1, let's assign 2 to num2, let's add them together and store them in sum. Right? We know that this is how we sum two variables together. This function wouldn't be very meaningful though, right? Because all this function would ever do was always add 1 plus 2. And when we add a return statement, return the number 3. So we want the function to work so that it will sum any two integer values. So we take a look at this and start thinking about what information does this function need from the outside world. It needs the two numbers. That's what it needs from the outside world. It needs those. Its function is to get those two numbers, have those two numbers passed to it, calculate a sum, and return the sum. So we're going to move the declarations of num1 and num2 from inside this function into our parameter list. So num1 and num2 were both ints. We move them into the parameter list. Right, we move them out of the body of the function. Right, remember, this is just like declaring a variable. Right, data type name, data type name. And when we have more than one, the list is separated by commas. Right, so now we've got this variable sum in here. We're still adding the two numbers together and assigning that to sum. Right. If you think about it, we now know that this function is supposed to return the sum that it calculates. Right. And since we're going to return the sum, we look at the data type of sum, which is an int, and now we know the return data type, right? It's the same data type as sum. So we can change this now. So now we have our complete function header here. We have the complete behavior. We needed to add this statement, return sum. And that gives us a function then that calculates the sum of two numbers. Now the thing is we might want to know, how do we use that function, right? How are we going to call it and use it, right? And that's the next topic. So now that we wrote our function, right, we want to say, how do we use this? So if we were going to write the function prototype, let's just go ahead and go back to our example here. Right, I'm going to kind of destroy the whole world, hello world stuff. Right. Remember our function calcsum. Right. So if I define it like this, int calcsum, int num1, int num2, right. Beginning ending curly. Now, don't know what I did, how I got those up there. What set of keystrokes I had. All right. We declared sum, and then we assigned to sum the value of num1 plus num2, right? And then we returned what was stored in sum, right? So that's how then we wrote the function. So in order to use it, right, we want to call the function named, right, call the calcsum function. Right, calling a function simply means we want to use it. In order to call a function, we call it by name. So its name is calcsum. We look at its list here, it needs 2 parameters, right? So let's just pass it 2 values, 3 and 4. Right? We end this with a semicolon. Right? Now, when I call this function, it's going to return some information to me. So I want to capture that and store it somewhere. Maybe here in main, I'll have a variable called sum as well. I can type. Right. And now I want to assign to sum the expression or the value that this function returns. All right, so I call my function. These are arguments. I'm passing in an argument of 3 and an argument of 4. Now let's just go ahead and build this. Notice I defined calcsum before I referenced it. Right, so I didn't have to create the function prototype. I get a warning about the sums being set but not used. We're going to ignore that for now. Like I said, let's do a run to cursor here. But remember, our program execution always starts with main. It does not matter how many functions we have, it always starts with main. So here in main, right, we've declared the variable sum. I didn't initialize it to anything. We have some sort of garbage value in sum. Right? Now, when we say step into, right, our code will then come up here to this function, right? And now when we come up here to this function, notice what's in the debugger watch window. We've got num1 has a value of 3, num2 has a value of 4. The way this works is when we call this function, the value of the first expression in this list is passed to this variable. So this variable gets assigned whatever the value of this expression is. Right, the next parameter in this list gets assigned the value of this expression. That's why up here, right, inside of this function, we say that num1, num2, and sum, these variables are local to this function. So we have the local variable sum. Num1 and num2 both show up under the function arguments, but this is how they get the value of 3 and 4. So now if we execute next line, sum will be assigned the value of 7. Right, now we're going to return that 7 back to main. So let's say next line, right, end of our function, next line. Now we're back in main, right? Notice main now has a value of 7 stored in sum, and our function, or our program would end at this point. Notice I declared a variable here named sum and a variable here named sum. These each have their own memory space. Whenever we declare a variable inside curly brackets, that variable is local to this. It has local scope. It will exist in memory from the time that this function executes until it ends, right? But only within this function. So main has access to a value named sum, a variable, right? And calcsum has its own variable named sum. The way this works is, let's do a run to cursor again. So now we're here in main. It only has one variable, local to main, right, named sum. We're going to do a step into. When we come up here now, what's shown in the watch window is what relates to this function calcsum. It has 2 arguments, right, num1 and num2 that are local to it, and then this variable named sum. Right. So if we just say next line, right, we're going to assign the value of 7 to sum. We're going to return what's stored in sum. When we leave this function, these variables go out of scope. They go out of existence. So back down in main, we can't access them. Right, so next line, we come back to main, right, sum has 7. Right. I don't have to name it the same. Right? What if I name this total? Right? Just to show you that just because they have the same name, it makes no difference. Right, so now, let's do a run to cursor. All right. So notice here in main, right, we have our variables now called total. Right, step into, then Our next line of code that we execute is right here. Inside this function, local to it, are two arguments, num1 and num2, and then sum. Right. We're going to, next line, we're going to add those two together, store them in sum. We're going to return the value stored in sum, which is 7. So this expression here is going to evaluate to the number 7, which is then assigned a total inside here. But when we leave calcsum, so here we're getting ready to leave calcsum, sum, num1, num2, those variables go out of existence. Back here in main, all we know about is this local variable named total, right, which now has the value of 7 in it. Right. We stop the debugger. As a matter of fact, right, to show you that, what if we tried to use num1? Right? What if I tried to set num1 equal to some value? 9. Let's just compile. We're going to get the error you expected, right? We get the error saying that this variable has not been declared. Just because it's part of this parameter list, this is only local to this function. Main doesn't know anything about what's going on outside of main. All main knows about are any variables that are declared here locally, or if we declare some global variables. Right? So we can't use something without declaring. Okay. A lesson we learned early on. Now, here's the other thing about implicit declaration, the warning again. So I'm going to take this, right, I'm going to move the code down here. So here we reference this in main, but we don't define it until down here. Without a prototype above, we'll see that we get that compiler warning. Warning implicit declaration of function calcsum. Right. In order to get rid of that, right, we can simply copy this, put this up here. I put a semicolon after it, and we'll say declare function, right? And now if we compile, right, that warning goes away about calcsum. I'm still getting a warning about my unused variable, right? And if we do a run to cursor, we still get the same behavior, right? We've just written our code a little bit differently than we did before. If I step into, right, my next line of execution is within this function. Same thing as before, same behavior. We simply had to declare the function's existence by putting its prototype up here because it was defined below main. It was defined below where it was first referenced. All right, so. All right, so we can enhance our example as well too by getting some information from the user. We don't necessarily want to hard code those arguments in. Right? If we hard code those in like we did, then we'll just get the same sum time after time. Right? So now let's adjust main a little bit here. Let's go back to calling this sum just to show that we can have variables with the same name in different functions. Right, and now let's go ahead and two variables, maybe x and y. All right, so we're going to say enter x. All right, so we'll enter some value for x. And we'll enter some value for y. Oh, let's not print out. Enter y. Address of y. All right, and so now let's just pass the value of x and the value of y to our function. Right? Make this program capable of calculating the sum of two variables the user enters. Right. All right, so let's do a little run to cursor again. All right, so now this pops up waiting for us to enter some value. All right, 45 for x. All right, and 30 for y. All right, so now here in main, right? Notice that we have X and Y, right? 45 and 30. Sum doesn't have anything yet, garbage in the memory. We're going to now, when we call calcsum, right, num1 we'll see gets the value stored in X, num2 gets the value stored in Y. It's order. Just because X is first in the list, this first parameter gets this. Because Y is second in the list, the second parameter gets it. Whenever we call a function, we have to have as many arguments in this list as there are parameters in this list here. Right, so we do a step into. Right, so now we can see, now that we're in the sum function, we have variables num1 and num2. Right, we have the local name sum. It doesn't know anything about X or Y. Right? If I were to just try to type in X here, it says it's not available in the current context. Right? So X, and if we were to type in Y, it says the same thing. It's not available. This function knows nothing about X and Y. So let me delete that and delete that. All right. And now we'll just add these two numbers. So next line, we can see sum has the value of 75 stored in its memory. We're going to return what's stored in sum's memory, the 75. We'll return back to main. And now we can see the sum in main has 75 in it. Right? Right. Similarly, let's stop this. Let's do one more thing. Let's show the order. Let's go ahead and swap. So now if I have Y and I have X, we're still going to get the same result, right? Addition is commutative. X plus Y is the same as Y plus X. But I want you to see that num1 and num2 will have different values this time, right? Simply because of the order. All right, run cursor. All right, so we're waiting. I'm still going to type the 45. I'm still going to type the 30. So now we're waiting to execute then this line of code. We step into our function. So notice now num1 has 30, num2 has 45. Because we had Y first in the list here, we had 30 stored in Y, so num1 got the 30. 45 was stored in X, so the value of 45 was passed to num2. Right? So this just passes copies of the values that are stored in X and Y. That will be our next topic about pass by value. Let's just finish this up and see that we'll still get the same result back, right? Num1 and num2 just got different values simply because of the order here. So order is important, right? And there's a one-to-one correspondence in the order. All right, I think that's just about the end of this section here. All right, so we finished that up, right? We went through all of that to show what happens. And we've been talking about the order of program flow as well. Right, we've stepped through this. So all this series of slides do is help you see what the order of program flow. So what order these are executed in, right? So we just actually did this by running through the debugger. Right? I'd recommend, as always, that you use the debugger then to see how your code works. Right? That's the end of this particular part of the lecture. When we come back the next lecture, we'll discuss pass by value.